Hello everyone, welcome to the Bodhi Academy. In today's PYQ series, we are going to solve PYQs of Standard 12 Physics, chapter Dual Nature of Radiation and Matter. Let's solve the first question. Stopping potential in photoelectric effect depends on A. Intensity of light, B. Frequency of light, C. Both A and B, D. None of these. So the answer is B, frequency of light, because stopping potential is related to the maximum kinetic energy of emitted electrons that depends on the light's frequency, not intensity. Coming to the next question, which of the following supports the particle nature of light? A. Interference, B. Diffraction, C. Photoelectric effect, and D. Polarization. So photoelectric effect is the emission of electrons from a material caused by electromagnetic radiation, such as ultraviolet. So electrons emitted in this process is known as photoelectrons, and this photoelectric effect proves that the light behaves as particles, that is photons. Moving on to the next question, state the laws of photoelectric emission. So the first law states that the velocity of electrons emitted is independent of the intensity of light and depends only on the frequency or wavelength of the incident light. The next one, photoelectric current or the number of photoelectrons ejected per second is proportional to the intensity of the incident light. The next one, for a given metal, there exists a certain minimum frequency below which the emission of electrons stop immediately. This frequency is known as the threshold frequency. The last one states that photoelectron emission is an instantaneous process. The graph shows stopping potential against the incident frequency for two photosensitive metals A and B is shown in the figure. Which of the metal A and B has the higher threshold wavelength? So from the graph we can make out that A has a smaller threshold frequency, so we can say that it has a higher wavelength. And B, write the expression for the maximum velocity of photoelectrons in terms of its cutoff voltage. So expression for maximum velocity in terms of its cutoff voltage is given by, since kinetic energy maximum is equal to E mu naught, so half mv square max is equal to E mu naught. So V max can be written as root of 2 E mu naught upon m. Coming to the next question, the figure shows the stopping potential V naught versus the frequency mu graph for the photoelectric emission from two metals A and B. So which metal A or B has a higher work function? So metal B has a higher work function because it has a higher frequency. And which metal A or B will emit electrons with higher kinetic energy when light of the same frequency is incident on them? So metal A will emit electrons with higher kinetic energy when light of the same frequency is incident on them. Coming to the next question, in a photoelectric emission, first one, stopping potential is constant. Second one, maximum kinetic energy of the emitted photoelectrons is constant. In each of the cases, which quantity of the incident radiation is kept constant? So stopping potential is constant, so which is given by EV equal to H V minus V naught. So the quantity of the incident radiation that is kept constant is frequency or wavelength. So maximum kinetic energy of the emitted photoelectrons is constant, half mv square max equal to h v minus v naught, and the quantity of the incident radiation is kept constant is frequency or wavelength in the second case as well. And why are all metal alkalis more suited as photosensitive materials? So work function of alkali metals is low, and therefore they have a very low threshold frequency. So they have a high threshold wavelength. Coming to the next question, an electron and proton have either same kinetic energy or same speed, in which case the particles will have the shorter de Broglie's wavelength. So we know that de Broglie's wavelength is given as lambda equal to h upon mv. So since the mass of the electron is less than the mass of the proton will have shorter de Broglie's wavelength when the electrons and protons have same kinetic energy as well as when it has the same speed. And why do bigger objects in daily life do not show wave-like properties? That is because they have bigger objects have wavelength that is very small and that is beyond any measurement. So that's why they do not show any wave-like properties. Coming to the next question, case A source emits photons of certain frequencies which are analyzed to get a spectrum in the visible region. Case B, photons with continuous range of frequencies are passed through a rare-filled gas and then analyzed to get a spectrum in the visible region. So what is the difference between the two spectra that are obtained? So in the case A, the emission spectrum will be obtained because the source of light emits certain discrete frequencies which are seen as bright lines. And in the second case, absorption spectrum will be obtained because continuous light passes through the gas and certain frequencies absorbed are seen as dark lines. Refer to the above graph and arrange the three metals in ascending order of their work functions. So from the graph we can see that metal C will have a less potential, less work function, metal B, and then finally metal A. And if the photoelectrons are emitted with incident frequency mu, which of these metal will emit photoelectrons of the highest kinetic energy and why? So metal A will emit photoelectrons of the highest kinetic energy because kinetic energy max is given as kinetic energy max equal to h v minus v naught. So less is the v naught, more will be the kinetic energy. Therefore, it will have more kinetic energy. Coming to the last question, the figure shows the graph for frequency of incident radiation versus stopping potential. So write the two implications from the observation of this graph which supports Einstein's theory of photoelectric effect. So the two implications from this graph are for both metals A and B. The stopping potential varies linearly with the frequency of the incident radiation. And for both metals A and B, the minimum cutoff frequency mu, called the threshold frequency, is different. So when supporting potential is zero. So both A and B will support Einstein's theory of photoelectric effect. Thank you for watching today's video. Don't forget to like, share and subscribe to the Bodhi Academy.